My name is Ron Munitz, and I have spoken in some of the previous Embedded Israel meetups, and I've spoken a lot of other places. I'm the owner of the PSCG consultancy. I had a couple of startups, still have actually. And in this talk, I'm going to actually present some concepts in working with MacBooks or Mini Mac or whatever as if they were Linux systems. Okay, so this is not going to be a very long talk, and as opposed to some of our previous talks in Embedded Israel and some of my previous talks in general, I'm not going to do like a serious deep diving, but I do think that there are some interesting concepts that are going to be happening here. So our objectives in this talk are to get an overview of macOS and a little bit of its Docker structure. We'll look at some products that can help you run Linux on macOS, in particular, all kinds of virtual machines. We'll also talk about Docker and see how we can use like Docker instances. Everybody uses Docker over Mac, especially if you want to develop something. To use it as Linux, especially to go ahead and forward displays and to go ahead and forward audio. If
One moment. Great. Glad to hear it.
Huh? Okay. I don't know what Siri wants, but she should be disabled. I'm glad you're glad. Yeah, this is one of the things why, this is one of the reasons why you want to use Linux, right? So we're going to do that. And of course, you can go ahead and when you code, just use Visual Studio Code and connect it with Docker extensions to Docker and so on. But this is not the purpose of this talk. And later I'm going to show a surprise that is a little bit it's a little bit challenging to show live, so I did some pre-recording. I don't commit that the recording is amazing, but I do think it will be useful enough. So the prerequisites to do some of the things that we talk about in this session are to have like a macOS device. I have a MacBook Pro with 10 cores and 32 gigabytes of RAM, and it's an M1 from 2021, which means it runs ARX64, it runs ARM64. And this particular laptop now runs the latest macOS Ventura, and I installed, the pre-installed, so we don't waste too much time, Docker, and it's one of its latest versions. And I think I just saw there's another update today. And XQuartz, which is an X server, okay? Another thing that I have here, it's a little bit of a spoiler, is actually Pulse Audio Server for macOS. So all of those were installed, at least the XQuartz and like the Pulse server with they were installed using Brew. You can also use MacPorts. You can also get all kind of packages in all kind of places, but it really doesn't matter. As long as they exist, you can do like the different so-called exercises in this talk and experiment for yourself. Now, there are some very important things about working with macOS and Docker. Docker infrastructure has progressed a lot in the last couple of years, but different versions behave in different way. This applies both to Docker and to other virtual machines like QEMU, and there are all kind of trade-offs. So sooner or later, Linux people use Mac, get upset and look for all kind of like tricks to work around all kind of annoying problems. So I do believe that in this session we present at least some of them, and we're just going to have to progress and see for ourselves. All right, so what it is that we want to do? We want to develop on our MacBook as if we were running Linux. Why? Because it's much nicer to run Linux, right? So there are so many reasons. And one of them is that every time most of the developers do something, unless they do, I don't know, they use some Flutter or use develop like for iPhones or develop maybe even like for Android, but or use Xcode or all kind of things like that. A lot of the development these days happens with containers and especially with Dockers. So it would be very, very, very nice if we already have like Docker, we use it for everything, we feel comfortable with it. and we could just use it to do everything, like watch, I don't know, videos on YouTube, like play movies, like test all kind of things. All right. So one solution would be to just go ahead, if we really use Docker all the time, and we need like to have like a Linux system, to say, all right, let's go ahead, take a virtual machine and use it. And for there is Parallels, which is really, really good. There's VirtualBox and VMware Fusion, which did not exist in the ARM macOS until a couple of months ago, okay? And there is UTM, and there's QEMU. Now, QEMU is awesome, it's great, but it could be like very complex to use to set up just like, I don't know, a Fedora or like an Ubuntu installation. So basically, one of the things that one can do is go ahead and use Multipass, which is a product by Canonical that allows you to start Ubuntu virtual machines on all major platforms like Linux, Windows, and macOS. So Multipass, I will show a quick example of it, perhaps, especially when showing like, hey, this is really, each instance is a different kernel. I'm not going to spend too much work on it. There is another thing that those of you who dealt a little bit with macOS may know, especially like with research, that, or even development, that you can relatively easily like create your own hypervisor. It's not the hypervisor like infrastructure, but there are APIs for starting VMs and for isolating components. So there is like there are a couple of like frameworks. Let's open that. And there is like the security framework, which is like the newer, and there is like the VM hypervisor. So if you run Mac, I mean, after like Mac OS 11 or Mac, I think, then you need to use like the COM Apple security hypervisor. Otherwise, you're going to use the Apple VM hypervisor. This is why it says that it's like deprecated here. Okay, but this is not like exactly the lesson here. So we're going to just we're not going to talk about it too much. Okay. All right. So let's say that I pretty much already said it like in my own words. But if we were giving this talk before October 2022, we'd have much less options for running virtual machines without Rosetta. Rosetta is like translating, hey, let's run x86 VMs on top of ARM and do like translations. And without Rosetta, you would not be able like to run a lot of like virtual machine constructs. So you would not have like VirtualBox or VMware if you wanted to like port your VTIs or stuff like that. And another thing is that some product, including QEMU and Docker, would not behave the same on different versions of macOS. So sometimes you could use Dockers with the macOS hypervisor framework, and other times you could not. And for this reason, until a couple of months ago, I think in version 4. Still in version 4.10 or 4.11 of Docker, you would actually have like some of like the significant performance boosts that are now offered as experimental, right? So there are several types of like virtualization frameworks. I slightly showed like the hypervisor. We can take a deeper look at it, and if somebody else has like deep understanding of it and want to submit to talk about it, perfect. Please go ahead. We'd love to talk about that. So basically, there are several problems with VMs. I believe that like the so-called best VM Parallels is and like most common one. It's commercial. It's of course closed source. It costs money, but it's very powerful. And a lot of companies say, hey, like maybe we can do some other things. Okay. So what can we do like for free or like without paying? We can use QEMU. So QEMU can actually be built very easily, can be fetched from all kinds of sources like pre-install, and we can go ahead and in some versions of Android emulator or Docker, depending on how we run them, and of course on Multipass, which I will present briefly, in a couple of seconds. It's this one, like this M is for multipass. We sort of get QEMU for free, okay? So some of the problems with QEMU, again, are, hey, it depends like on the macOS version, depends on the QEMU version. If I have, let's say, Docker, and on one version, I may have a very old QEMU, and with some parameters that are not optimal. Why? Because if we try to make some things optimal, like the macOS would crash completely. And these things are problematic and annoying. And in addition to this, like inconsistency between versions and instability, at least in some versions, you can't do everything you want necessarily. If you want to do like to connect like your hardware to USB with USB, for example, then you need to know how to download the devices. So you need to know a little bit more about QEMU. And some of like the ready-made solutions will not do that for you. So multipass will not do it for you. I'll show multipass like in a jiffy. And you need to know like what you want to do. But it is not always possible to, even like for QEMU, to support like all kind of hardware easily, even if it would work on Linux for all kind of like considerations. One thing that like I found really annoying is what happens if you have like a combination of like USB 2 or USB 3. How do you define the QEMU bridge? So there are all kind of things like that that are not so trivial. Okay, so if we went ahead and want to check other projects QEMU, I'm not going to do it right now too much, but we're just going to do like PSAX or something like that, grep for QEMU, and then see how they run like their system, okay? So I'm still not talking about Docker, all right? I will soon, but basically, if I want to go and look in Docker, how it would run like QEMU, and then it would be something like that. That would be QEMU system ARC 64. We can see here by the application Docker app contents that it is part of. It is part of like of this Docker. It will have all kind of like parameters, like which accelerator to use, hypervisor framework, which CPU like use like the same model as like the host, machine would be virt. IMM off. This would cut off some things that you need in order to have like a much more capable things. And I'm pretty sure that this happens. There are all kind of combinations that happens because HVF does not support some things. Okay, so this is the memory. This is in Docker like the maximum number of processor that you could do. In the other framework that they use, it could be 10, and then it actually selects like a kernel. Like from Linux Kit is like what I do for that. Append is like the parameters, okay? We can see some of the things that we have is VPN Kit Connect. I'm sorry for talking like very, very, very fast. I do it on purpose. And like the VPN Kit Connect actually tells you, hey, this is how I'm going to be how the Docker like machines that I'm using are going to be connected. Because at the end of the day, Docker runs also like QEMU. So there are all kinds of parameters that show, hey, this guy ran QEMU, and that's like what we have. And we'll get to that a little bit later as well. All right. So speaking of VMs and QEMU, I promise there is multipass. So here is like an example for this guy. We have like library, application support, canonical multipass, yada, 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 yada. And if I went ahead and just tried to see, let's see what is like the version of this guy. Oops. Okay, I need to I need to escape it, I suppose. Yeah, so it's 6.2.0. It's ancient, okay? I mean, so there's already 7, and basically it's like not that amazing. So this virtual machine was actually just, I mean, I can access it from like relatively easily from something that is trivial to set up. I'm not going to even show how to set up like multipass because it's just so easy. Go to multipass run and do like whatever. And if I look here on this one, I can see that, for example, we have here a Linux kernel Board 5.40 generic, and the machine itself is AR yada yada yada, and I could go ahead, compare the parameters to whatever is listed here. We see Cortex, the CPU is Cortex 7 2. I don't know how many cores are assigned here. SMP only 1. Memory only 1024. I could customize some things, but a lot of things I can't, okay? If I go do proc CPU info, this one matches like the other guys. And if I went ahead and let's just do uptime on this one, and I put another, okay, this is the same, this is the same one, okay? So let's get rid of this shell. But I did put another virtual machine. So we can see slightly different times, okay? Like this is 3433 and this is 3515. I spawned them like in different times, like a couple of seconds, one after the other. And one of the like nice things of using like QEMU is that you have different kernels, okay? So even if it runs like the same kernel version and everything, you have different machines. You can do kernel development. You can test all kinds of things. If you set loop back devices, they're not shared, and you can work. This is like a VM, okay? And the tricks that I'm going to show for forwarding video and audio, they also apply to this. And the trick will be exporting display and exporting full server. And we'll see it later, right? So this is one example of a VM. In this particular case, it's multipass, okay? And if I went ahead and so what are the instances that are running, I can see that we have two different instances. We can look at the parameters. We can see that we have here like the, it's not exactly boot from, but like or BIOS, but like from the EDK project, and we can see all kind of models. What we can do with this information, we say, hey, we have QEMU. If I want to have the same exact same virtual machine that somebody like Canonical configured for me, and I want to make it more powerful, I want to have it multi-core, okay, I'll give it SMP8, or I'll go ahead and give memory of 8 megabytes, or I'll go ahead and expose different kernel parameters, and then I can do a lot of things that I want. I can expose external hardware, I can get a lot of things done from the work of others, which is pretty great, okay? The exception or the problem is that not all hardware pass-through will be supported. So if you want to cheat, starting from multipass and have like your Linux distro and do hardware bypasses is like a pretty nice hack. You need to understand a little bit QEMU, and you need to understand a little bit like what are the parameters. Okay? All right. So any questions so far, friends? Let's see. Okay. All right. Let's check the chat. All right. So this is let me just recap this. One of the things that we can do is go ahead and use emulators. So QEMU, it's very customizable. It's literally everywhere. And one of the nice things is that we can, if we manage to make one image that runs on QEMU and runs well, like on Linux, it could run also like on Windows. It could run also on MacOS. So we can, let's say we have developers that use different things and they do need like hardware access, or they do need to check also kernel, to work on kernel, and not only on user space. For this, Docker will be no good. Then we can provide them like with a customizable QEMU and work with that. Like most people don't want that. Most people, they already use Docker, right? And they would want to just use that. So that's what we're going to do. We're going to use a Docker image on our macOS, but I will show how to make something more accessible. In particular, graphics, I/O, and audio. And I mean, when in my example, I will show audio like for playing audio, not for recording audio, but that is also possible. So we're going to very, very, very quickly and extremely securely show how to export an X11 display and how to do pulse audio. And you can also go ahead and run VNC server inside, in particular X11 VNC, inside your Docker and export that as well, okay? So I'm not going to talk about that, but I'm going to start now with doing X11 forwarding. And those of you who did a lot of this protocol know there is also like Wayland, and there are like other things that one can do, but I'm just going to be simple here. So the theory for running graphics would be like this. The macOS would have an X server. In our example, it's X Quartz that is easily installable from Brew. And your Docker will be an X11 client. We'll export display and we'll set the credentials properly. For example, we need like an X11 cookie, X30 file, but we can go ahead and say, hey, I don't want any security. On our hosts, do xhost plus, and then we'll be able to run X11 applications, okay? So for this demo, I actually did a couple of things. So this is the setup that I told you about in Docker. We just want to make sure that Docker runs, and I made an image, macOS forwarding, installed some of the packages that I want, which is X11 apps and Pulse Audio. I also installed, this is very annoying because if we want to have like a fully fledged Linux system on Docker, we need to take care of systemd, for example. And if we don't take care of systemd, because we usually don't need it on Docker, then snap, which is the now recommended way of installing application in Linux, would not work. So it gets pretty annoying. And in this particular image, I installed Firefox also, and I will show later in the slides like more or less what are the steps to do that. And I just set up, also I installed Firefox not from Snap, but like from the Mozilla PPA repository. And we'll see that also, but I'm not going to show all the steps because it will take time. I could do it if somebody wants. I can show it like separately. Okay. So what we have here basically is what we have here basically is a macOS terminal, and I can go ahead and like run exeyes, and we can see that the application here is X Quartz. So when X11 server works, when I do it locally, okay? Now, I'm going to go the X Quartz, and you know what? I'm just going to get rid of this particular window, okay? And I'm going to Control-C here. And if I do xhost, it tells me access control disabled because I did it. I did xhost like plus. If I do xhost minus, then if I will go and try to connect from another device like my Docker, I will have all kind of like permission issues. So if I am on my Docker and I do have xeyes or xcalc, it's going to be, hey, I cannot open display. I could go ahead and say, okay, display is, pay attention to this address. Host Docker internal. What is host Docker internal? It's going to be 192.168.65.2. Why? I will explain in 2 or 3 minutes from now. But if I go ahead and say, hey, the display, forward the display to this guy, of course, I can export the environment. I'm doing it like now so that you see like the steps. And then do xcalc or xi. It will tell me something different. Authorization required. Can't open display. Why? Because it needs authorization. So now we'll go ahead. Vert, the vert is not the word, but like remove like access control. We'll do the same. And voila, now I have something that runs like from within my Docker. So the display problem is done, okay? And you can see that I can also have input and I can also have output, and everybody's happy, all right? So this is part one. I will, as I said, I will explain what is this address? I mean, who knows this address? If we go ahead and do IPA and a default Docker bridge, like a subnet, I see a different address. And if I do IP route, here I installed a couple of packages. I installed IP route, I installed the packages for ping, and I installed IP route, IP utils, IP route 2. This gives the IP2. I see that the default route is this IP. I mean, who even knows this IP? If I go like on my host and I do like, I don't know, I have config, we will not find like in Docker, I can show later, like in Linux, we will not find this subnet anywhere. So what's going on? So if I wanted to go and see like what's going on, I have it on my slide, but I want to prove it to you, okay? We will see that we have all kind of processes. One of the hosts, which is called VPN kit, and the Docker Dockers that are being run. And here we see COM Docker virtualization. We'll talk about like the difference between this and QEMU. It has kernel parameters of VPN kit connect, and it's going to tell like, hey, like you connect. There is like where will I see it? On the slide I will see better. But basically, the VPN kit, this VPN kit, it's going to take care of network bridging inside a virtual machine that essentially runs Docker. Okay, so please stop me on questions. They're not. I mean, it's not too interactive. This is why I allow myself like to run. But you know, if you want to ask something, don't stop yourself. Okay, I don't want you to be bored. So yeah, so that's what we did. Like we tested the prerequisites on the host. We saw like the eyes, okay? And then like on the target, and these are the things that I installed, like X11 apps. This gave me Xcalc, and also it would also give Xeyes. We saw what happened like with the authorization. We forwarded the display, and we forwarded the display to the address that is actually provided to us by VPN kit, okay? So this would be the case in several settings of Docker, and I'll talk about the Docker later. So we will have it both here, and we don't see it like with our own eyes, or with QEMU, that there will be all kind of parameters that would deliberately say, hey, VPN kit connect to this address, which is what we saw when we did ping to the internal host, and this port, okay? All right. And in the host itself, it says that the host IP is 192.168.65.2, and this is why it knows like to do like the magic when we resolve it. So basically, I just told you how these things work, so I'm not going to go over these slides again, but all the networking shenanigans are due to VPN kit, and this is true for Windows as well, for Windows with WSL when you run Docker. On Linux, and perhaps I will show later, just to prove the point, it does not hold. So we've done the display forwarding, and this is exactly like what I've done. On the host, we did access plus, and we took care of it. But this does not take care of audio. And for audio, what we're going to do is something a little bit different. We're going to have on our macOS, we're going to start a Pulse Audio server. Again, from Brew. I will not show it, but take it for granted. If you copy paste something like this, it will work. And we need to load it on the Pulse server. And we can go ahead and prove that it works by just playing a sound. So I'll do it twice, once on the host and once on the target. So here again, if I just do like PA play, it will say, hey, connection failed. And if I do this and use another environment variable, just like we use display, then I'll use it again, okay? So basically, if I have a sound and I have audio, I can do all kind of things. I can go ahead and install a video player. I can go ahead and install, like, I don't know, like start Firefox. And I'm pretty sure that yeah. And look, this Firefox runs on my host, okay, on XQuartz. So I can go ahead to youtube.com and I can search, let's search for embedded Israel. I've never done that. When I think about it. Yeah, this is definitely not our talks. UFC or this looks like my slide. Linker scripts, whatever. It is supposed to work. I don't know why it doesn't load. An error occurred. Amazing. Maybe it just doesn't. Let's look for whatever. Let's check out Ronaldo and Messi.
שומעת?
Commercials.
מאחר בטירוף.
Con ese brazalete de capitán. Se hace raro ver a Cristiano en estas tierras tan exóticas después de haber estado en el fútbol de máximo nivel.
Did you hear that? Did you hear it? So I just wanted to prove that I was not lying. If we run like a Firefox and you managed to hear it, and everything is okay. Did you guys hear it? So the video, heard the sound? All right, great. So like a noting, all right, fine. So basically, if we manage to do these two things, then, I mean, we're pretty much okay. We're pretty much good. And we can run almost everything we want, which is pretty nice, okay? So here, like, in order to set it up, only thing we need to do, like on the target, is tell it, hey, this is your pulse audio configuration. So we need to get rid of like previous configuration, copy to it, or in Docker bound mount if we want to. This is like to be like more orthodox. And the definitions of like whatever we want to have like with the host, and give it like the server, and that's it. Like we're done. It's like the same method. So it's pretty straightforward. And if you can do this, you can run like entire desktops if you want. And so it can be like pretty convenient. Just one thing, I mentioned it, but I did not like go over like the slide. There is actually an advantage. There's some, it can suck to go ahead and have Docker that has like Snap. And if I want to, for example, install more complicated packages like Firefox that are now bundled within Snap. Snap is like, it's like a sandbox. It installs things that are like sandboxes, okay? Which pretty much looks like the macOS packages. When you install something, then you would have like these folders that have all the dependencies and everything combined, at least most of them. So in order to not depend too much on your environment, there are similar solutions for Linux, and the canonical one is Snap. So unfortunately, by default, Firefox would require Snap to install. So you can go ahead and say, hey, I don't want Snap, delete it, and do pinning so that it will not go like from the Ubuntu whatever release and install a PPA that I'm not explaining exactly what it is, but these are steps. You could also find it elsewhere. And if it interests you and you want to reproduce the steps, just ask me. I mean, you can ask me directly, or you can, I don't know, comment in the videos if when I publish it, and I'll help you with that. I'm happy to. So you can go and essentially take off like these things, and you can go ahead if you want like a fully fledged system with systemd. You can go ahead and macOS, just instead of running Docker, like running Bash as your first process, you can go ahead and run init like systemd. And in Linux, if you want to do it and you have systemd, and you run in privileged mode, then it is very, very, very likely that if I did something like this in Linux and did like a demonstration, then our conversation would stop like in the middle, because Docker and systemd would try to take over the virtual terminals. Virtual terminals are what you have when you have like Control Alt F1, Alt F2, and so on and so forth. Like they would intermix, and it can be super annoying. Unfortunately, sometimes you need to be privileged in order to do all kinds of things. So in Linux, it's a little bit more complex, and in macOS, it's actually much, much, much nicer. Why would you want to do that? That is another question. Okay. So basically, what we covered so far is we installed Docker Pulse Audio and Xquartz on our host on the macOS, set up Ubuntu latest container, and we saw how to run both graphical and audio applications by taking advantage of X11 forwarding and Pulse Audio forwarding. So while doing it, we actually saw a little bit of the considerations of Docker framework. Okay, questions so far? All right. It's a late hour and it's, like a pop-up meetup, so it's really okay. But if you have questions, please feel free to jump. So basically, I mentioned before a couple of implementations like in Docker, and I said, hey, one of the problems or like features with Docker on macOS is that different version of Docker and different versions of different versions of Docker and different versions of macOS behave differently. So what one can do actually, when I mean differently, is one of these things. Like they can go like to the general tab of the Docker settings, and you can see here the use virtualization framework. It says uses virtualization for creating and managing Docker desktop in macOS 12.5 and above. If you have macOS 12.4, you can still use it on much older Docker version. It will be under experimental. So we're not going to consider OS XFS, but depending on your versions, Docker and macOS, you would either use on the older ones by default gRPC fuse for file sharing and working on things like that, and then you would have to use QEMU as your virtualization framework, your virtualization actually application, and not the Docker one that implements the virtualization framework directly. Or on the newer one, you could use virtiofs, which significantly improves your file system performance. Now, if you use volumes, by default, your performance will be better than if you use bind mounts. But basically, this makes things better for both for several reasons. One of them would also be, it's like a nice side effect, that the new virtualization framework also allows you to share more resources with it. If you use the QEMU at the time of this talk, which is almost end of January, it's mid-January 2023, then the Docker version that you would have would only allow you to run like 8 cores, whether it is significant or not. I showed a little benchmark. I'm, of course, just going to show the result and not do all of it. And I'm going to tell you, okay? So again, if you want to see how these things actually change something in practice, you would go ahead and do like PSAX, for example, grep Docker. And for the virtiofs, you will see that this is like the process that is being run, okay? The parameters are somewhat different, but not that different. And if you use the gRPC one, you will see that it uses QEMU system ARC64, which just for the sports, let's go ahead and see its version. So This is terrible. It's a disaster. It's 5.2.0. At least Multipass had the courtesy to run 6. something. Okay, so yeah, this can explain a thing or two. And I'm telling you for sure, like more than one client of mine was working with macOS to build all kind of things, and they would go ahead and say, "Hey, like on Linux, it will build much faster." So actually, using the new virtualization framework does help, and let's go ahead and look at a little bit of the numbers. Okay, so all right. So I will first go ahead and tell you the little surprise I mentioned before the meetup. We talked about running macOS and on top of it Docker or virtual machines. We talk about several forms of Docker, and now it utilizes either the Mac hypervisor framework or QEMU. And another thing that we can do, actually, is just to boot MacBook into Linux kernel directly, no emulators, no hypervisors, and run Linux on the Mac OS. And in this case, we don't need any more virtual machines. And this is possible with something that is called Asahi Linux, that I will show. I did like a pre-recording of like the setup process of it, so that you'll see that it's not very frightening and to see like what happens and what you do. But you can go ahead and just go like to Asahi Linux, and it will tell you all kind of things. It will run an Arch Linux on your Mac OS. It does not support everything. For example, it does not support audio. And it also does not support, from what I saw today, like HDMI. But apparently it does support graphic acceleration. Right now it supports using GPU, which is pretty nice. And it will not be. I took a video of it like with my phone, and I'm not 100% sure it will be so nice to watch, but I'll try to at least like show you like the demo of how things look like. Okay, so I'll do it after I tell you what is like the end result of like the comparison. But yeah, you can go ahead, install it. It's pretty straightforward, and if you don't like Arch Linux, then you can also use Debian port of it. Okay. So what is the benchmarking that I did? What I did is downloaded Linux kernel tarball. I did it yesterday, so it was the latest one was 6.2 RC4, and then actually today 6.2 RC5 came up. So which means that soon enough we're going to have the 6.2 kernel version. If you have been developing kernel, and of course, if you've been in our first meetups when I was talking about versioning and stuff like that. So one of the things we're going to check is like the extraction. Most ARM processors are notorious in compression, decompression, and we're going to build the ARM64 default configuration on as many cores that as we have. I did assign like all 30. I did set the Dockers to have 32 gigs of memory. And for Docker that does not use like the virtiofs, which means like the new framework, we could only allocate 8 cores for reason that I said earlier. This is what QEMU that they have supported. So I did it 3 times, and also compared like to native Linux, that is to Asahi Linux, okay, that I installed directly on it. So let's just see like the results of it. The tarball extraction. I put another thing, like I extracted it on the Mac OS itself, and surprisingly, it was even slower than the slowest Docker. It took a bit more than 10 seconds, and the fastest was Docker virtiofs. And this is not how you benchmark. You need to test many times and check all kind of things. Check when caches are hot. Check when nothing is in the caches, and so on. But the tarball extraction of the new Docker framework that uses the Mac virtualization framework took 6.25 seconds. With QEMU and gRPC, it took almost 10 seconds, 9.95. And Asahi Linux, the native Linux, that doesn't use like any hypervisor, it took 6.412 seconds. This is the tarball extraction. This would not convince anyone to go ahead and ditch like Docker for their build. But then the building of the Linux kernel, which could take a while to build, this gave more promising results. So it's not relevant for macOS because you don't build kernel in macOS. You could, but it's not that trivial. And why would you do it? And Docker with virtiofs took 6 minutes and 24 seconds, more or less. And the native Linux took 5 minutes and 22 seconds. So imagine you have something as terrible as the AOSP. So the speed up can be much more significant. So it's pretty nice. There is like a reason if you use like a MacBook, sometimes you have to use MacBook. Sometimes you need, let's say you need to build for ARM and you need something local, not use, now there is, I believe that all cloud providers, because Amazon has been providing a ARM they've been providing ARM cloud instances for like a couple of years. I think Google started providing their instances either last year or this year. Azure started providing their ARM instances this year, and perhaps their providers also do that. So basically, if you don't use cloud providers, let's say you fly all the time, like myself, and now that COVID is done, hopefully, then it could be very useful, especially if they say, hey, you have to build, let's say you work in a company. Unfortunately, I've been working with such a company that did not want to spend the effort on having a cross tool chain. And they had like a story where they like on x86 they were building a lot of things like Node.js, and the bootstrap would segment it, would have like a segfault every once in a while, like across the bootstrap. So yeah, so everybody like were using Mac anyway. So yeah, I was using Mac also, and the build times were not very nice. So actually going native did help, and going from gRPC to the virtiofs implementation of Docker, it found itself.
I didn't get
was
that.
Worth the while.
Could you try again?
It was worth the while. Okay, so passing like from this to that. All right, as you can understand, I usually don't speak or use MacBooks. I just did it for this. So I'm sorry about the interruptions, right, of this assistant. So look at the speed up. I mean, it's more than 2 minutes from like one implementation of Docker to the other one. And this is significant, okay? Like, it is really significant. And this minute from the native Linux to the Docker and with virtiofs is also very significant. So yeah, so by this, we can conclude the comparison. And I do want to show you like how the installation process goes. But before I do it, let's summarize what we've seen, because we're pretty much done. We saw some VM solutions over macOS like multipass. We talked about the other VMs like Parallels, and like the newly introduced for the Apple Silicon VirtualBox and VMware Fusion solutions. And we talked about Docker and the different Docker types and how networking shenanigans go there. And we show how to actually go ahead and run like Firefox with display and audio. We saw some YouTube video. We saw Ronaldo and Messi over there. And then I talked, and I will show soon, if you're interested, like a video of like how the installation of Linux on Apple Silicon MacBook works. And essentially, I told you like the numbers. I did not show it, but I did not fake them. I hope you trust me on that. So this pretty much concludes the talk, except for the video demonstration of the installation. If you're interested, I could also like I will just actually do like some speed ups and show a recording that I pre-made. And the reason I did recording is, one, it takes time, and two, in one point you need to reboot the system, then you can do whatever you want. All right, so I'm going to prepare it. And does anyone have any question? You still with me? Okay. So what do you say? Should I quickly go? So should I set up like the video I pre-recorded and show you how Asahi Linux is installed, and show you like the look and feel of it? I'm sure there are better videos in YouTube, but I didn't even bother to search for them. So I'm going to do that anyway. And if anybody like wants to sign off, that's great. The meetup was spontaneous, and I suppose some people will look at the recording anyway, so I will upload it sometime. And I just wanted to give you some time to ask questions, like if you want. So what do you say? I'm just going to proceed and show you the recording, okay? But I need a minute to prepare it. So I'm going to stop the screen sharing, and I'm going to take care of that, right? Sure, see you. So I'm actually going to just play the first video that like shows like the download, installation, and like the first phase of the setup, so that it will be part of like this recording as well. Audio may not be ideal, but it will be just a little bit nicer, I guess. All right, so bye for the people who sign up, and hi to people who still stay in YouTube, although I'm saying it's not what we're going to see now. You should probably see it elsewhere, okay? It's just part of like the talk, so like, why not? So I'm just going to go ahead and replay it. What I'm going to put, okay. So now is how we're going to just download, say, okay, I'll get to it now. I'll get to it like right now. I'll just play this recording, and for the other ones, I'll skip them because there is like a lot of waiting. And perhaps in another video, I will introduce some more of like what's going on there. What I'm going to quickly show now is how we're going to just download Asahi Linux. There are additional ports that do not use ARC, but will just use the quickest way. It's just doing exactly what they say here in the website. So let's go ahead and let's go to the announcement. But re-rolled now, but it's good enough. We just go, run this, make sure you have enough disk space, and that's it pretty much. So let's go ahead and just do that, right? This is definitely going to take a while, and I'm not going to tire you with all that. And you can see the progress both here and here. It needs some sort of super user permission. It will ask you for some prompt. So, hey, make sure you're familiar with your documentation. So please, by all means, go ahead. Make sure that you are. This is the GitHub wiki page of the project. And we're not going to look at it because this recording wants to be short. So go ahead this. And of course, we want to have like either a very advanced mode or not. And we will enable expert mode. The default is to not do that. So you can just not do that. It will tell you whether you have like all these kind of things. And it will ask you like questions of like what you want to do. So here in this example, it's going to go ahead. It's going to use the disk utils and do all kind of things on that. So here I have like a couple of partitions here. And basically, we don't have to use that. And I'm not going to give the comments on it anyway. I would usually install things in somewhat different way. But we're just going to go ahead and basically resize the partition. It's not a big deal. It's like LVM like in Linux. We're going to use that one. And here it's going to tell it, hey, it has like a significant disk space overhead because of FFS snapshot, yada, yada, yada. You can select all kinds of things like that. But we are going to just go ahead and decide what is the division that we want to use. Okay, so we can select like sizes. We need to go ahead and see like what is the minimal size that we really need. Okay, so let's go ahead. We have like free space of 242 gigs, and we just need around 60 gigs in order to install that. So we'll select the size for the existing partition, and let's just go ahead and say that we want 90% for that because that's what I want. Let's do that. System may appear to freeze during the resize. This is normal. So we are going to do that, but now I'm going to like pause. So maybe in another time I can go ahead like cover everything, but we've seen like in the previous time that we start installation and it does all kind of things and it asked us like, hey, how much space you want to use? Like it's going to essentially have to do a boot that is toggled by recovery, okay, or like the startup option. Like if you do like the long press on your Mac power button and don't release it, then it will give you later the option like to choose between the systems. And after installations, it will give you like you can also have it like without pressing the button. So we can see that like it aims to resize like the Apple file system. Here in this case, it resizes it from over 900 gigs to almost 900 gig. And after the resizing, it always tells you, hey, press OK to continue, and give you like all kind of like additional steps, like how would you like to partition things and so on and so forth. So the next video will show that, and I'll probably cut myself like the record itself like in the middle. But let's see. This is done. It will tell you resize complete. Please enter to continue. Yeah, I mean, that's where we started and that's where we end. We'll do enter. And it will tell us, hey, now that we've resizes, what we want to do like with the different partitions. So we have now the free space. Hopefully it is enough and I wasn't too cheap on it. And we're just going to install to the free space. And it tells us, hey, which ones would you like to go ahead and install? So you can select one of these things, and basically we can do some very interesting things. Like macOS, ever since forever, they use like UEFI, and we can have like an EFI that will load Ubuntu and then will work in a very embedded ARM-ish way. But we're not going to do that. Both like the third and fourth options are very much like for development, and especially if you want to like develop Linux kernel over there, or you want to practice your Ubuntu skills or whatever. And we're not going to do that. So I'll just go and use the Asahi Linux desktop. We could use the Linux minimal, but a little less cool for the kernel. That's what we're going to do. We'll download the OS package, and it needs 15, right? So we're just going to tell it, just for fun, to use like all the available space. Of course, this could affect like repartitioning, but we're just going to use that, and that's it. And we'll call it, just for fun, PSCG. And it said, hey, if we pick like a non-default option, like we need to check it out. Like this is the macOS version we use for like the boot firmware. So right now I'm actually using like 13.1. This is 12.4. Let's hope it works. It should work. Let's go ahead. And we're going to go ahead. It creates like a new stub macOS. This is actually like for when you do like your recovery mode, and like you can manage like multiple operating systems over there. We could also override that, but we won't. And yeah, I mean, it will take a while. And I'm going to stop the recording. Actually, don't really know how to. Okay, so just like a quick note, we have here like a ESP. ESP is the EFI system partition, and Ubuntu is Ubuntu. And M1 is some sort of like experimentation ground for like second stage Linux loader. So when you run Asahi, you'll actually see, hey, that it starts Ubuntu, and then it starts grub. Now, of course, things can be optimized and modified, and this is like where you can go ahead and say, hey, I want this Linux kernel, or I want this RAM disk, and so on and so forth. And the nice thing is that like once you are like, in control of like Ubuntu and M1 and 1, then you can utilize like your ARM porting experience or Linux porting experience, or use Linux command line experience, and like, customize your shiny new distro. Okay. So, I just want to go ahead, and it will go ahead and keep its extractions. It will take a while. So this is not interesting. I did it like very quickly. So it's not that organized. And the last part would be right before the reboot. So let's see it as well. And we can see that here, like we have like all kind of EFI. I called it like an installation PSCG ASA when I selected like how to call it. All right. So basically, we can see here also there are some locations in the installations. There are locations some after. So we can go ahead, can actually see that it's extracted here, and we have the P list. We see it like it's Apple, it's Apple jargon. Okay. So I'm going to play like the last part here. It's not so long, and then there will be the rebooting that I didn't save. I uploaded it to YouTube, and I hope that it works. I didn't really check it. I only recorded it like with the camera. So let's see this. Here you can see that after everything, we have like these extraction phases. You can see that we actually have additional locations here, like for the rootfs and like data and the EFI partition. And let's do what it says here. Continue the installation. And it sets the new operating system as the default boot volume, which means that if we want to have our macOS back, we're going to need to change that. So here it is. We need one more step. And we're going to enter here. And it already told us that, hey, we've done that. We should be happy. And so on. So we're going to do now enter. And we need to wait 15 seconds and install. Now I'm going to stop it. Okay, so I did wait 15 seconds and install. And you know what? I mean, I can show like now I have like another video of like 15 minutes and I'm not going to, I mean, it's not exactly published. I will send it myself like as a comment. And let's see. I'll open it. I'll show some things here. And with this, I will conclude like that presentation. That's what I'm going to do. Let me show. Yeah, that's me like showing how to get to like recovery mode. And I'll just mute it. I'll show the display. Okay. So after long pressing, we'll have like the Mac here, loading startup options. Yeah, I took it like with a phone. Okay. And it will have like the PSG Asahi here in addition to Macintosh HD. So later on when you boot, you can go ahead and select Macintosh HD and that's it. So if we go and boot it, this looks like the macOS is installing itself, but it's still not there, okay? I mean, and we see that macOS recovery started, it's examining volumes, it's going to do something like on its first run. And here is another part of like the installer. We have like a Asahi Linux installer second step. Again, press enter to continue, you'll be prompted here, you prompted there. And it would go ahead, say, hey, system volume, yada, yada, yada. Enter your username, enter like your password. This was your macOS password that you need like to set. And later you're going to actually also like set up your users over there. So it's going to tell you, hey, what is like a username? It's going to ask you for this username and password. And then it says installation complete. You will reboot. This is something waving. See, that's what happens like when you're an engineer. But you can this is how you type. This is when you're not like a marketer, right? But yeah, you should be happy. I mean, I could just duct tape some camera and do whatever. So here, I don't know if you managed to see it, but it said like advanced options for Arch Linux. There is like a loading, it mounted like the system, the ASP partition, and there it goes, like the default distribution. I didn't do like anything too special, okay? I just went and let it set up whatever it is, the default. This is version 3.2.53, which is the default of it. Going to be a couple of like next. I'm going to quickly skip it. I just set whatever was relatively fast for me. I set the users. This is like, actually, this is where like we set the user screen in the user screen. So it says the PSG and like the login would be wrong. The PSG, of course, rules. It's a great company. And then like when you're done with everything and the setup and the finish, then it's going to go ahead. And this is how your login will look when you boot the computer next time. So you'll put this, you put the password, and what I do later on is probably connect to internet or like see what's going on. Here we can see, and this, if I upload this like part of the video, we can see that there is like WLAN 0 interface. I actually used, I connected it to, I did connect it like to Wi-Fi. Is one of the things that I did here. using like the KDE interfaces. I prefer other window managers, but yeah, that works and that's okay. And of course, prefer terminal. And then I can ping the pscg.com. Network works, that's great. Go ahead, open a browser. And actually, I think it's the same video we saw here. Oh, Ronaldo did not score that one. Never mind. Scored enough goals. And what I did here was, this is how I did like the benchmark. I got a tarball. I extracted it. We can see like in uname -m that is an ARC64. This is why the def config would go to this one. And I built like a kernel. And I also, this is where I did all kind of like installations of packages. Like the first time I was going to build, it was missing some of like the dependencies, and this is where the kernel is built. And other things that like I showed here is that, hey, like if we install like Mesa utils, we can see that the GLX gears like works. So hey, GPU works, may have graphic acceleration, and yeah, that's what we've done. And this took I did one build, like I don't know if the numbers here match. I think I actually did like an extra step comparing like to yesterday, or because I ran the GLX gears, or I don't remember why, but like I did the experiment of building it again. So if your eyes are like very, very, very sharp and you looked at the benchmarking from this stock, then don't worry, I just did it again, of course, from cold boot. And anyway, this is not exactly how you benchmark, but building the Linux kernel on Asahi Linux is better than the better macOS Docker, okay? So this is the end. This is like a proof that we're done. This is a proof that we build like kernel modules. And this is, and yeah, this is like what proves this kind of things. And it's pretty nice, okay? So with that, our first meetup, or my first talk at this meetup after a couple of years is concluded. And I really, really, really hope that you found it useful. And I hope that we will get back to face-to-face meeting very, very, very soon. And that I will see a lot of you, or whoever is interested, in the next meetup. This was announced, a couple of hours before it actually took place. So it's really okay that like very few people attended. I was going to talk to myself anyway. So I really hope you find it useful. And that's it. We're going to meet again, hopefully very soon. And stay tuned. So have a good night if you're in Israel. Have a good day or good afternoon if you're in other places. And I'll see you around. So thank you.